Welcome to this developer skill sprint, the Internet of Things with Bluetooth. I'm David I, and let's get started. This skill sprint works with Rad Studio XE7, Delphi, and C++ Builder, and also AppMethod's September 2014 release. It works on Windows, OS X, Android, and iOS devices using both the C++ and the Object Pascal language. Skill sprints are a quick tip and trick about programming, 20 minutes, and then we'll do some Q&A. Bluetooth has been added in XE7 and AppMethod September 2014 release. There's a new unit called System.Bluetooth, presents a multi-device API for both classic Bluetooth and Bluetooth LE. There's a new component called T-Bluetooth LE for low-energy device connection, and there are classes for classic Bluetooth, including the Bluetooth Manager, adapter, and device classes. The graph here shows what you can use Bluetooth for on each platform, whether it's for app tethering or for Bluetooth low energy, or using just the RTL API in your VCL and FireMonkey applications. And the new T-Bluetooth LE component has several events that you can hook for connecting and discovering low energy devices. And then when you get the data from the device on a characteristic read. More about that in a minute. First, you can use Bluetooth now with app tethering. In previous releases, app tethering was only provided for network connections. Now you can also have a choice of the connection via Bluetooth. So to implement classic Bluetooth in your VCL and FMX apps, you'll obtain an instance of a T-Bluetooth Manager. You can discover remote devices and pair with them, connect to the paired device, and then exchange data. In app tethering, you'll see that you just change the property of the connection from network to Bluetooth. For Bluetooth LE devices, you use the component or an instance of T-Bluetooth LE device. And that allows you to discover services and also read information from the devices. And if it's provided, writing data back to the devices. So to obtain the instance of the device, you'll call the start discovery method, or the manager will give you discovered devices and you can choose one from the list. Bluetooth LE is part of the Bluetooth standard. The generic attribute profile, or GATT, is a set of standard specifications for finding certain types of low energy devices. The first is the profile itself, and inside of the profile there can be one or more services that the device provides. And within each service, there can be a set of characteristics, which are values and properties. For example, heart rate, beats per minute, or on a scale, the weight, maybe the unit of measure. Now, if a device is not GATT, then you can try using the discovery as part of the component. Otherwise, you'll need to contact the device manufacturer to find specific information about how to connect and program those devices. So I give you the link there, and there'll be some more links at the end of this skill sprint for finding out if the devices you're interested in have standard specifications or whether they have custom APIs that you'll need to work with. Let's look at two demonstrations that use Bluetooth support in XE7. The first will be app tethering, which was introduced in XE6 using network connection, now supporting Bluetooth. And then we'll take a look at a heart rate example that uses Bluetooth LE and a heart rate monitor that I'm wearing. So I'm in the IDE, and I'm going to open up one of the samples. And I should say that all of the samples I'm using ship with both Rad Studio and with AppMethod. So the first example is app tethering and its use of Bluetooth. This is one of the standard applications. It's the media player. I've got a project group. So we've got the media player, a commander that's a VCL application, and a command that's a FireMonkey multi-device application. The media player is what you see here. It's a standard application that can load a video, play and pause it, clear the video, change the volume, and so on. It's been updated to add the T-Tethering Manager, and you'll notice a new property called Allowed Adapters that has two choices. network, which was what app tethering supported before, and now Bluetooth. The T-Tethering app profile, once you have a connection between your tethered apps, can facilitate the actions that take place. We've got a couple actions in this example. One is to play, pause, and to clear the video. If we look at the player command side of our tether application, it's got a button for finding the players, and they'll show up here in this list box. We've got the tethering manager. Again, it's also set to Bluetooth. And we've got the tethering app profile. There's a volume control with using a track bar that'll change the volume of the movie. And we've got a button here for playing and pausing that when we click is going to run the remote action through the tether manager to play or pause the video that's over on OS X. So we can run a Windows VCL app. We can run a multi-device app. In this case, I'm going to use my Android Nexus 7, and I'm going to run the player on OS X. Now, before that takes place, I need to go over to the Macintosh side and make sure that I've connected the two devices together with Bluetooth. So if I go to Bluetooth, you'll see the Nexus 7 has already been paired. It's not connected currently because I'm not asking the Nexus 7 to do anything. If you haven't paired the devices before, you'll want to make sure they're paired in advance. Also, you should be aware that the more devices you have paired, the longer the discovery will take. So let's select the media player, and we'll go and build and run this on OS X. All right, here's the media player running on OS X. We'll load a video that I have. This is Big Buck Bunny, and it's a high definition. We can use the user interface of the application to play and pause the video. And I'll go back to the IDE and I'll enable the multi-device application that will command the OS X media player. We'll run this on our Nexus 7. So here's the controller application running on my Nexus 7. Let me zoom down the IDE so we can see it in action. So we tap on the Find Players button on our Android, and the FMX Media Player, which is the name of our OS X application, is there. And it's selected. We can now hit play, and notice the video is playing. Hit pause. We can change the bar, and notice that the volume control is being changed. So that's Bluetooth tethering in action from an Android device to an OS X application. The second project I want to demo uses the Bluetooth LE component to monitor heart rate. So this application has the Bluetooth LE component. It's enabled by default. And we've hooked 3 events on nDiscover devices, on descriptor read, and on characteristic read. There's a scan button and some user interface for displaying devices that are found, as well as the heart rate, and this little heart will animate after it finds the heart monitor device. We can also read the characteristic for the body location of the heart rate monitor. I'm using a Polar H7 with a chest strap, so it should find that the strap is connected to my chest. We've got a button here, and that will do scanning, so it calls do scan. And here's the Bluetooth LE component calling discover devices, passing a timeout. This is in milliseconds, so that's about 2.5 seconds. And in this case, an array of services it's looking for. And this is set to the UUID for Bluetooth of a heart rate monitor. We get that value by looking in the GATT specifications for Bluetooth LE. And all heart rate monitors, if they're standard GATT, will use 180D in the first long word. There's 2 characteristics that we'll read, and each of those has a UUID. 2A37 will get us the heart rate measurement, and 2A38 will get us where the sensor is on the body. You can also specify other parameters for discovery. There's 3 choices. Just put the timeout with no specific device or array of devices, and it will look to find all the GATT standard devices that it finds using Bluetooth LE. You can also specify a list of UUIDs or an array of IDs. So since I only want to look for heart rate monitor in this app, I'll just pass that UUID for the heart rate service that I'm looking for, 180D. At the end of discovery, we'll find out if it found any devices, so it'll dump to my memo log how many devices were discovered. We get a device list that's passed to us, so we can get its count. And then if the count's greater than 0, then we'll just take the first discovered device, display the name, and then we'll use the Bluetooth LE to get services and see if we can find any services for that device. And if no services are found, we'll display that in the memo. Otherwise, we'll call this procedure that will go out for the services found, and it'll dump out in the memo the services that the device provides. We'll see if one of those devices is a heart rate service. And if it is, then the service is found, and we can set up to get the characteristic of heart rate measurement by calling get characteristic and passing that heart rate measurement characteristic UUID. And also the sensor location. And then we'll keep monitoring the heart rate. And the way you monitor a heart rate is you can subscribe to a characteristic that might be changing. And different devices have different characteristics. Some of them will notify you, and you can subscribe to it or unsubscribe for the device and the characteristic ID. And then to display the result, we'll get the data bytes, and based on the standard specification, we can find the bits that are used for the sensor location as well as for the heart rate. So let's take a look at this running on iOS. And I've got my iPhone here, and we'll take a look at the application in action. I clicked the scan button already, so it found the CardioSport category device. It's a Polar H7, and there's its the heart rate UUID 180D that was found. And now it also read the data of the sensor location characteristic. That gave us bits back, and there's an enumeration to turn that bit pattern into a string. In my case, I'm wearing a chest strap, so it shows up. And then there's the beats per minute. So if I move around a little, running in place, for example, I'll get my beats per minute moving up a little more. And then I'll sit back down and I'll calm down. And eventually my beats per minute will slow down. Same application works on Android or any other Bluetooth LE compatible device. And there's a range of heart rate monitors that you can purchase that subscribe to the standard GATT information so that you can find those devices. Over on the Bluetooth developer portal, we can see the different approved GATT specifications. If we scroll down, we'll find the heart rate service. If we scroll down, we can find the heart rate profile and the heart rate service. For the heart rate profile, it has a device information service and the heart rate service. We look at the heart rate service, it'll give us information about characteristics that are available. So for example, the heart rate measurement, the body sensor location, and the control unit. Down here, it'll tell us that, for example, the heart rate measurement has a mandatory property for notifying, so you can get notified as the heart rate is changing, or you can just read the data based on a timer or some other mechanism. Also on the Bluetooth developer portal, we can get to the GATT specification characteristics page and see the different characteristics that have been adopted. So for example, the body sensor location, it's agreed that that'll start its UUID at 2A38. That's where that number came from in our code. And down here at the heart rate measurement, 2A37, which is the other UUID we used. And each of these has additional information about the bits that are available, the sensor contact status, the heart rate value, and so on. The body sensor location, 8 bits. The choice is chest, wrist, finger, hand, earlobe, foot, and reserved for future use. And back in the heart rate source code, you'll see the body sensor location is an array of strings where we'll use the value to index and get the string chest, wrist, finger, hand, earlobe, and foot. And here also on the developer portal is the heart rate service viewer, and its assigned number 180D. So again, these numbers for UUIDs are built into the specification. So any heart rate monitor that is GATT standard will use that assigned number for the heart rate service as well as for the characteristics. And over on the Bluetooth page as well, there's a list of smart devices. These are devices that adhere to the standard. And if we scroll down, you'll see the type of product, different heart rate monitors made by different manufacturers. And for me, if I scroll down to Polar, here's the H7 heart rate monitor is one of those standards. And there's one last sample in the Bluetooth section that I'll just point you to. It's the Explore Devices LE sample. And what it does is it lets you look for devices across the range of GATT devices. And it does that by not passing any parameter to start discovery other than the default timeout. And then it will display all the services that it finds and then allows you to navigate through the different characteristics. Let's take a quick look at this Explore Devices LE example running on my iPad. We'll click Find Devices, and it'll go out over Bluetooth LE and find whatever it can see. And then if I select on this, you'll see a couple different devices, an Apple TV and a scale. So we can select the scale, for example. And it says, okay, that current device is the Wahoo scale version 1.3. We'll get the services that are available. And here's some information like the battery service and so on. We can say, here's the characteristic battery level, and we can go and get the value. So it's at 99% of battery. You'll notice available operations get highlighted based on reading the characteristics of the different device that was selected, in this case, the scale. And you'll see, for example, the battery is just a read only. It wouldn't make sense to write a value to the battery. Power state, manufacturer name string, temperature measurement. Notice the temperature measurement has a notify operation, so we'll get notified when the value changes. I just point this quickly. It's available as a sample. You can build it, and if you have some Bluetooth LE devices, they'll show up if they have a standard GATT profile, and you can then do some exploring of those devices and what capabilities they provide. The samples that I showed you are included in XE7, both the C++ and the Object Pascal versions. You'll find them in the directories that I show, mobile samples, device sensors and services, Bluetooth, and in the RTL tethering. Additional information is available on the doc wiki using Bluetooth, using classic Bluetooth and app tethering. Then I've included some Bluetooth.org URLs to information about the different standards that are available for Bluetooth, Bluetooth LE, about GATT, and how to find the standard specifications that are available for categories of Bluetooth LE devices. In the next skill sprint, Nick Hodges, one of our Embarcadero MVPs, is going to present aspect-oriented programming using D#. Nick is the author of Coding in Delphi, the great book on programming that you can get from leanpub.com. That skill sprint will take place next Tuesday, the 23rd of September, at the usual time, 6 a.m., 11 a.m., and 5 p.m. If you don't have XE7, you can download the free trial now and try out all of the new Bluetooth support that's available in XE7. And now it's time for Q&A. Can we use Zigbee or Z-Wave home automation? Those devices usually have a sort of base station that you can talk through a REST interface or some kind of TCP interface, and then they convert whatever data you send to them into radio frequency signals to do things like unlock doors and so on. We covered that. I used the Z-Wave, Mi Casa Verde. That was in our, what was it, February, Jim? January, February webinars, I was controlling
the Rad in Action one, yeah.
The Rad in Action. I was controlling light switch and a door lock. So you can do that. In that case, I was using the REST components to do a send and get the status of the door lock back by doing a REST request. So, Giuseppe tried the Explorer devices but didn't find any devices. If the devices you have are not GATT standard, if they're proprietary, then you need to contact the manufacturers, or they might have a developer site where they document things. With the resources, if you look on my blog post, I put the link in the chat window. You can click on it or copy and paste it. I have all the links and also links to the slides that I put in SlideShare this morning. That's my blog post for the skill sprint.
We don't have the video up on the screen right now.
I have links to all sorts of resources and the samples, and the SlideShare is up here. It's on the Embarcadero SlideShare area. Bluetooth has those set of standards, and if the devices you have adhere to the standards, you can query, and then through the methods, you can query the devices, you can query the services and characteristics that the device have, and that's what the Explorer does. In the case of the scale, you'll notice when in the T-Tree view, it didn't display all of the names of things because the Wahoo scale is part GATT standard, for example, getting the battery level, getting temperature alerts, and so on, getting manufacturer string. But they have a different non-standard set as well. In fact, the ID doesn't map specifically to one of the standard GATT UIDs, the first long word in what we would call a GUID or UUID. I think it was 1901, I think is the number hex it uses, and it has some other things. But you can go to the Wahoo Fitness site, and they have some documentation. They have a developer portal. So it's a long-winded answer about why maybe you can't see the devices. You should be able to see them if you go into your Bluetooth scanning on your Mac, your Windows 8.1, on your iPhone and your Android phones. When they're scanning, they'll see devices, but then if you want to do something, you'll need to pair with one of them. The Explorer does a similar thing. It's just listening for devices, and I showed the code. It just, discover devices. You pass it a timeout. You might also set the timeout a little longer if you're writing your own code. So so if it's not finding them, they're either proprietary. Like I have a blood pressure cuff made by Health Labs, and it's discoverable. You can see it. There it is. You can see it, but it doesn't. I can't connect to it. It doesn't have a standard GATT protocol interface. And Giuseppe's saying they have a beacon Bluetooth device. You need to look at the documentation from the manufacturer to see if it's GATT compliant or not. At the same time,
Bluetooth LE as well.
Yeah. At the same time, look at the proximity sample, which is one of the samples we ship. It has a server and a client. It turns your desktop or whatever the server you run, quote unquote, you run that proximity example on. It creates its own GATT, in a sense, stack. It creates a profile, service, a characteristic, and starts transmitting. And then there's the client for proximity that can find and looks for this server, and then it can query and it can get the power level and then can calculate an approximate distance. And that's, in a sense, part of what beacons do. All right, fine, change basic. Why it's doing that, but okay, go to webinar. So you'll need to, all of the samples are in the links that I have on my blog post that ship with the product, and they're also on SourceForge. So here's where they are on, oh, I didn't make that a link. Funny. I'll make that a link. But on SourceForge and with the XE7 product, all the samples are in mobile samples, device sensors and services, and then in the Bluetooth folder for C++ and Object Pascal. And the proximity sample is in there as well. It's also on SourceForge if you go there. So in a sense that you can I turn my Macintosh OS X computer into a beacon, broadcasting, right, a signal, and then I can use the client on my Nexus device or my, whatever to see how far away I am from that sender. So you can use the Bluetooth LE device class, which I talked about earlier in the slides, to find and scan for Bluetooth LE devices, including Bluetooth LE beacons or chest heart monitors or oximeters or blood pressure devices or scales or whatever, and then query what interfaces they have, what services and what characteristics. The other thing is you'll use the Bluetooth Explorer. There's this little subscribe button. What that does is there's a method available on a Bluetooth LE device class that allows you to be notified if a characteristic value changes, if it has notification. You saw those attributes in the lower right-hand corner, and if that notify is one of the attributes, and you can query to see if it has a notify attribute. You can look at the code in the Explorer, and then if you subscribe in a sense to be notified, then the on-read characteristic event will fire when the device notifies you, and whatever your handler is for on-read characteristic, just as you would do it yourself by requesting a read of a characteristic. If it's a notify device capability, then that same event will fire and you can get the data. So check out the Explorer source code, Explorer Bluetooth LE source code, and all the other samples as well.
So here's a question here from James. He says that the Bluetooth UUIDs in code were big, long UUIDs, but the IDs on the website were short 4-digit numbers. Can you explain the relationship between those again?
The codes that, if you look at the UUIDs that are used, the first long word of the GUID or UUID matches the hex code from the Bluetooth standards websites that I link to. So, as I mentioned, 180D for, I think, heart rate monitor. If you look at the source code in the heart rate monitor sample, you'll see the first part of the UUID being that number. The rest of the bytes of the GUID or UUID are basically the same. They're all the same bit patterns. They can be used for other things depending on the device. But ultimately, when you look for and discover look for a specific category of device, or if you just say discover all the devices, that's that method that I showed. If you just put the timeout amount, or if you don't even put the timeout amount, it has a default value, then it'll find all that it can find, and then you can get the device IDs back, and you can use the device. You get a list back after discovery of devices found, and you can go through them and look for names. If you're looking for a specific one, you can look at the UUID they return. You get UUIDs for the services. So everything seems to use GUIDs these days. So including these device profiles and services, so that they're unique within their category. So that's the first part, the long word. If you've never looked at a UUID before, it's documented. There's a long word and then some bytes and then an array of bytes at the end. And they're used, those other bits and bytes are used for all sorts of other things. The only thing I really care about is the first part. Let's see. I tried to use on discover device event in Bluetooth LE, the component started scanning, the event does not fire, only the event on end discovery. On end discover device. On discover device, let's see, after the timeout. The timeout is how long the scanning will take place, Casper. Same with app tethering when you were on the network. If you had a busy network, you needed to set the timeout longer while it was, when it did its broadcast, listening for tethered apps to respond back, whether they were tether managers or tether apps. You can look at my Find Tethers blog earlier this year, I think in April or May. So it's that timeout is the amount of time that the component and the classes underneath it and the code will wait for devices to be found. All right? It's not, that they start coming to you as they come. If you put 10 seconds, nothing's going to happen for 10 seconds, and then you'll get a list of devices found, and you'll get a count. From that, you can also get a count of the number of devices found. And if it's 0, then you didn't find any. Let's see. If I have 25 heart rate monitors around me, they would have 25 different GUIDs. Well, no. If they're GATT standard, they'll have a common GUID, whatever it was, 180D in the first part. Then inside of that, once you find them, you can look at information about each of the heart rate monitors. They each will have the manufacturer name. They'll have probably a serial number, a version number of the device, like Wahoo Scale. The manufacturer was Wahoo Fitness. The version number was 1.3. So you'll want to display all of that information to choose which heart rate monitor alpha that you want to do something with. Or maybe you're monitoring all of them and you want to display all 25 of them because they're hooked on 25 people in a gym or in a hospital or whatever. The GUIDs are for the category of the device or the services it provides. Then you need to query the information that's inside the characteristics for each of those services. All right, and again, look to the manufacturers and the Bluetooth standard, that GATT specification documents, for example. It will tell you what the bits are and what the characteristics are for the approved standards. Heart rate monitor, blood sugar. Oh, the cyclists are really into this, so there's a bunch of cadence and things like that that are in those standards. And so the first long number in the GUID, it's reserved by Bluetooth 1800 hex to 18FF hex. After that, then there's custom device. Like my oximeter for my health labs shows up as 1900. The scale shows up at 1901 hex. And then Casper's saying, yeah, there's two different parts. There's two different frameworks for Bluetooth in XE7. There's Bluetooth Classic or Classic Bluetooth. That's a set of classes. And then there's Bluetooth LE. It's a separate framework. Now, over time, we're going to merge everything together, whether it's network, Bluetooth, or other kinds of connections to the internets of things. But for now, you'll need to use the two frameworks if you want to go find all the Bluetooth things, Bluetooth Classic devices and LE devices. Robert's asking about, is Bluetooth LE available in Windows version 7? Not as a standard. There's some people who have installed Bluetooth stacks for classic Bluetooth on Windows 7. In the work that we've looked at and the documentation, let me go back to that one. This is the slide share. It's Windows 8 Plus if you want Bluetooth Low Energy from Microsoft. So 8.0, 8.1. And for OS 10, it's there. If you want to have a LE server, 10.9, what is that, 10.9? 10.9 and beyond. For iOS, it's 5 Plus, and if you have a server app, 6 Plus, and Android 4.3 Plus. Classic Bluetooth's available with app tethering, except on iOS. On iOS, to do classic Bluetooth, you need to sign an agreement with Apple. And so manufacturers have done that for some of their devices. So contact Apple and you can license a classic Bluetooth technology set, libraries.
So
Go ahead.
as a developer, I would need to contact Apple to obtain that license to do that. If I want my app to implement classic Bluetooth, is that correct?
Yes. Yes, and that's what manufacturers do for iOS. So that's why it doesn't have the green check. We probably could have put an asterisk there. I think it goes on to explain that you need something from Apple if you want to use classic Bluetooth. I mean, my device has classic Bluetooth, and I can see the blood pressure cuff, which is classic Bluetooth from iHealth So they've signed some agreement to get the stuff that they need in their app from Apple. But for LE, you need Windows 8, and now I guess it's Windows 8.1. And
so there's a question here if you can use tethering to copy files from an Android tablet to a Windows PC via Wi-Fi.
And you can send any data you want between tethered apps.
Yeah. Let's just send strings or streams, and that covers everything.
Yeah, streams. And it might take a while. There's a question here, Winston was saying, what range does Bluetooth have? Well, that depends. Regular Bluetooth is probably, at least 100 meters, maybe more. Bluetooth LE is about half of that, but maybe more. It depends on if there's walls and what they're made of, or atmospherics and so on. But you can go to the Bluetooth.org site. You can read all the specs to get the information, the range that you want.
Does this work with XE5?
No. Bluetooth is XE7. This is an XE7 feature. Brian's asking, are most manufacturers adhering to the GATT specs? It depends on the manufacturer. I gave you the link down here on my blog post, so go there and then click on this link here, Bluetooth LE Smart Devices, and we'll bring that up. Here's manufacturers that are, if it has the Bluetooth Smart logo, you have to get permission to use that. These are manufacturers that for these types or standard, approved standard devices and their interfaces. So I don't have the Alitech technology devices for heart rate monitor, but that'll work. Alutech, Serena has a Zebra. I don't know who makes the Zebra. Maybe it's Zebra. I'm not sure. I went to Best Buy and I picked up for like $40 or whatever the Polar H7 because I saw that it was on the list. So you just need to look on this, or as you look at devices, you hear about them, news and whatever, go to their manufacturer sites and see if they're Bluetooth Smart, if they have that logo, or if they have technical specs, see if they support a GATT standard. If they don't support a GATT standard, you can still program with them. You just need to figure out the hex code for the first long word of the device ID, UUID. The Discoverer or the Explorer will find that, usually find that for you. Yes, if they are using this official logo, then they have to provide the GATT standards or adhere to the GATT standards for the types of devices there are. There are only X number of GATT approved standards, and you can go down again on my blog and go look at GATT specification documents, and here you'll find these are the list of GATT-based specifications. So, alert, notification, heart rate service profile, find me, health thermometer, time, power, transmission power. So there's some of these that are approved, and so
I notice I don't see one for a remote control car on here.
Yeah, I don't either. But then again, you might be able to get its battery level.